Okay, girls, let's solve this question together. Question 8, June 2013, about sound waves. First of all, state the range of frequencies of sound which can be heard by a healthy human ear. We said that the range of frequency range between what and what? 20 hertz to 20,000 hertz. Now in the mark scheme, they said that you can write any range between 15 to 25 hertz here, and here from 15,000 to 25,000. But it's better to write the one that we know it, that is between 20 to 20,000 hertz. The second one, compressions and rarefactions occur along the path of sound waves. State in terms of the behavior of molecules. What is meant by a compression? When we have a compression, what does it mean? It's the regions where particles are close to each other. Or you can say that the air pressure is high, raised, increased, okay? This is a compression. Rarefaction, regions where air particles are far apart. Or air pressure reduced or decreased, okay? State the effect on what is heard by a listener when there is an increase in the amplitude of a sound. We know that amplitude is related to loudness. So high amplitude or increase in amplitude, it means that this sound will become louder. A decrease in the wavelength of sound. Okay, we didn't take a relation between wavelength and any of the properties of sound or sound waves. But here what we can say, that when the wavelength decrease, what is the other thing that will change? Frequency. You remember the formula? V equals wavelength times frequency. Wavelength and frequency are inversely proportional. When the wavelength decreases, the frequency increases. So when the frequency increases, what is the thing that will be affected of the sound? The pitch. What will happen to it? Higher pitch. Okay? Great. A student carries out an experiment to find the speed of sound in air. He stands facing a high cliff and shouts. He hears the echo 1.9 seconds later. So at the beginning, here's the cliff. He moved a distance. We don't know this distance. It's unknown. And he shouts, and he heard his sound after 1.9 seconds. He then walks 250 meters further away from the cliff. Now, after this distance X, he moved 250 meters away from the cliff. Then at this time, he did the same. He heard the echo 3.5 seconds later. Calculate the speed of sound given by this experiment. Okay, now girls, now we know speed of sound, you have to use this formula, 2D over C. But we don't have the distance here or here. We don't have the distance. So what we can do, but we only have one distance, this one, 250 meters. Can I find the time for this distance? If I can't find the time for this distance, I can find the speed of sound. How I can find it? I have the time for this distance, X. X, the time of it is 1.9 seconds. Now, 250 plus X, this is the new distance, the time of it is 3.5. So if I want to find the time for the 250, what I do? I subtract this time, 3.5, minus 1.9. That's what I do. I subtract these two time. What I will get? I will get the time for the 250 meter this time. Okay, so here are the steps. 3.5 minus 1.9, 1.6 seconds. So I use the distance, which is 250 meters. Okay, girls? But remember that you have to multiply it by 2, because when you measure the sound back and forth, it will reflect. This is the distance for the sound, okay? Not only one way. So 2 times 250 over 1.6, the answer is 312.5 meters per second. Okay?